timer over here, so I remember to stop it. Okay, limit existence theorem. Nice little formula here. So, the limit as x approaches a of f of x exists if and only if and only if limit as x approaches a from the left-hand side of f of x equals the limit as x approaches a from the right-hand side of f of x equals L, some number. Oops. Where L is a real number. So that should give us a bit of comfort in that you don't have to worry about complex numbers in calculus. There are no I's in calculus. So yeah, everything is real. So in this case, then the limit as x approaches a of f of x would be L, since as you approach from the left and as you approach from the right, you get the same thing. If we approach from the left and the right and we don't get the same thing, then you have a problem.
Do we do it wrong, or does it get harder from there?
I would say no. We'll have more steps from here, but no, we didn't do it wrong.
Okay, because you said we had a problem.
Oh, no, you would have a problem if these two limits aren't equal to each other. For example, back over here, like these two. This one and this one. See how you have two limits? Mm-hmm. And you have limit from the left of -3 and the right of -3, and they both equal 7 over 6.
Yeah.
So that means the limit as x approaches just -3 equals 7 over 6.
What about?
So, yes. So here's the problem. This one, right? This one, if I tried to find the limit as x just approaches 3, it would be does not exist. Now, it approaches 3 from the left, it gives you negative infinity. And as I approach 3 from the right, it gives me positive infinity. But since those two things aren't the same, then if I take away the plus and the minus there, limit as x approaches 3 does not exist. We would put DNE. And we're going to do something like that. Excellent question. Okay. So, here we go with these. Find each of the following from the graph. So we're going to start with that one. The limit as x approaches 2 from what?
Left.
Left, because it's a little minus sign. So what is y doing as x approaches 2 from the left? Say that again? Yes, good. So, like here's 2, right here. That's where x is 2. And as this approaches, so I'm getting closer and closer to that line, notice it's going up. So that's why this is infinity. The next one. What about limit as x approaches 2 from the right?
Infinity.
It's also infinity. Does everybody see that? Because it's going up. Now, what if I just asked you, what is f of 2?
Infinity. Well, wait.
Doesn't exist.
Yeah, there isn't one. Does not exist, undefined. There is no f of 2. All right. So the question is, Does the limit as x approaches 2 exist or not? Why or why not? So, go ahead. No, why not? There's no defined number. Now, sometimes you will see, and they will have infinity here. That is not necessarily wrong. It's just not an actual limit. Because how can you limit something by infinity? That's not a limit. It's going on forever. It's just telling you what's happening with the graph. So you will see that. But technically, the limit does not exist because those two limits, even though they're equal, they're not equal to a real number. So the limit as x approaches 2 from the left, and as x approaches 2 from the right, are not real numbers. It's infinity. So, say you have this problem on a AP Cal test, or just like the actual AP test, or on my test, because it's basically, they're the same kind of test. If it's a multiple choice question, can we make that bigger?
No, it's like the 2 was like going into the line.
Oh, yeah. The multiple choice test, it would never have an answer that does not exist in infinity. So you wouldn't have to worry about that. And if it was a free response question, they would accept either answer. So you could put infinity as an answer for that limit, or you could say does not exist. Both are correct.
Would you count them both correct on here?
And I would too, yes. Yep.
But so there is no limit on it.
No, because I mean, think about it.
How can you limit affinity?
Yeah, exactly. But it's more of it lets you know something about the graph. So sometimes it's very important to have it written that way because that tells us something about the graph. It tells us that this graph is going up forever. And if I just put does not exist, it wouldn't give me as much information. All right, next part. I have another equation, so I'm looking at example number 2. I want you to just try to fill those in. Write real lightly. If you're not sure and want to erase, that's fine. It's hard to learn without trying something on your own. Hi, Ashley and Harvey. We miss you. Faith, what is so going on with your phone?
I'm texting Ashley.
She's sad. She doesn't have class.
She's apparently cold and sad that she doesn't get to be in this class.
Absolutely. I'll post the video.
That's what I told her, but she said it's not the same.
I know. But at least she'll get to hear me talking. It's not as bad as just posting the notes like last year.
Oh my gosh, I was so confused when we did that because I had to know what happened when.
Right. Now I get that.
I just can't move.
But you can't ask questions online.
Well,
Yeah,
she can. She can email me or put it in Google Classroom. I've had tons of students, believe me. I'm doing that all the time.
You have a bunch of online students.
Yeah, I mean, quite a few. Okay, so limit as x approaches 2 from the left of f of x. Brooklyn, what do you think? It is. Now let's look at it. Oh, there goes my timer. Hang on.